Today we're going to discuss Chapter 3.5, Molar Mass. Some background information on what molar mass is. Molar mass is a mass of a given substance, either a chemical element or a chemical compound that's measured in grams. And then you divide that by the amount of its substance, so which is measured in moles. The expression is made in grams per mole. A mole itself can be defined as a mass of a substance containing the same number of fundamental units that are in exactly 12.000 grams of carbon-12. So essentially, molar mass is the mass in grams of 1 mole of the compound. This number can be calculated using information found on the periodic table and in the chemical formula. You must consider the quantity of each element that is in the compound before you can go and figure this out. So for example, H3O has 3 hydrogens and 1 oxygen. Therefore, whenever you account for the mass of this compound, you must provide that you have 3 hydrogens in the compound with just 1 oxygen. So example 1, we're going to find the molar mass of carbon monoxide, which is CO. So that you know you have 1 carbon, 1 oxygen, so you're just looking for the mass of 1 mole of each. So 1 mole times 12.01 grams, which is the atomic mass, is going to be equal to 12.01 grams. And this canceled out moles because you took 1 mole, which is what you have, of the mass. So it cancels the moles and you're left with the grams. Then you find the mass of 1 mole of oxygen, so the same concept. You're going to cancel out moles and take the atomic mass. And when you multiply across, you get 15.9994 grams. Then once you do this step, the second step is to add the 2 weights together. So you're going to add 12.01 grams to 15.9994 grams, and you get 28.0094 grams, which is the average atomic mass for carbon monoxide. Okay, so we're going to do an example where there's more than one of an element. So example 2 is finding the molar mass of HCl04. So that means that we have 1 mole of hydrogen, 1 mole of chlorine, and 4 moles of oxygen. So just like in the last example, since there's only 1 mole of each of these, you're going to take 1 mole and multiply it by the atomic mass, which cancels out the moles. And then when you multiply straight across, you get the mass for each element in grams. Then you're going to take the 4 oxygens, and you're going to find the mass of 4 of those. So you're going to take 4 moles instead of 1 mole like these, and multiply by the atomic mass, and that'll cancel out the moles. And once you multiply across, you're going to get the weight in grams. And so to find the total molar mass of the compound, you're going to add them up just like you did in the last problem. So the average atomic mass, or molar mass, is 100.4586 grams. Example 3, we're going to find the molar mass of a way more complex one. Each element in this compound has more than 1 mole. So carbon has 6, hydrogen has 12, oxygen has 6. So you're going to take the mass of 6 moles of carbon. So 6 times the atomic number, canceling out the moles, gives you the number in grams of carbon. Then you're going to take 12 moles of hydrogen. So 12 times the atomic number of hydrogen, canceling the moles out, it gives you a value in grams. And then you're going to take 6 moles of oxygen times the atomic mass of oxygen, and cancel the moles, and it gives you the weight in grams. So to find the total, you're going to, like the molar mass of the compound, you're going to add them all together. And so the molar mass of this equation is 180.1566. And that's chapter 3.5, molar mass.